Right, so through this video, let us quickly look at how do we build GUI applications using Java, especially with event-driven programming. So here I have a project called GUI in which I created a package1. This doesn't make sense at this stage, so let me delete that because we'll get into those imports a little later. So I create a class called calculator, and this being a GUI class, I would extend the JFrame class, and the JFrame class is part of the java_x.swing package. So let me import that. So I have the JFrame class imported from the swing package. So now this calculator is the child class for the JFrame class. So let me start writing with the members. So I have here the buttons. So the J button, add, subtract, multiply, and divide. And I also have the J label, copy1, copy2, and result. I have the J text field to take the operand 1 and operand 2, so should we name it as JTF1 and JTF2. That's the two text fields. And then I have the J text area. Let me give it a name, JTA. Right, so I've got all these components that get added to my frame. So I'm trying to build a calculator application where I have 4 buttons which will represent addition, subtraction, multiplication, and division. And I've got 2 operands for which I created the labels, and then I have the 2 text fields, and then I have a result label which also has a text area next to it. So what I'll quickly do is I'll import all these classes because they all are not part of the standard lang package, but instead they're all part of the java_x.swing package. As stated in the class, the java_x.swing package is more contemporary than the traditional java.awt package, which is for the abstract window toolkit. The abstract window toolkit is usually not used for the components, especially because the AWT package is more system dependent, operating system dependent, and the swing package is system independent. So that's why we choose to work on the java_x.swing components. So all these components that you see here, the J button, the J label, the J text field, and the J text area, they're all part of the java_x.swing. So these are the members. I would also create some panels so that I can add them to my frame class. So private J panel, JP1, JP2, or should I name it more appropriately, JP North, JP South, and JP Center. We wish to split the calculator into 3 portions, the North, South, and Center. And I will also import the panel class. So that's with the members of the class. Let's quickly go ahead and build a constructor. So the constructor is the method that actually builds the entire look and feel of the calculator. So let's keep it public. The class is a public class, so public calculator, a no parameter constructor, and this is where I start setting the size of the calculator. Let's take it like 300 by 300. So 300 here is more of pixels. This dot set title of, let's give a name like calculator. And then I should start adding the components. So I would now add the components. This dot, the panels have to be created first. JPN is equal to this dot. The JPS is the one which has got the buttons. JPS is equal to this dot add buttons is a method that I wish to build a little later. So this method returns a panel and that is assigned to a reference called JPS. And then similarly I have the JPN, which is the north panel. So I wish to create a method called add operands. So the add operands method, which I would write a little later, will return a panel object which is referenced by the JPN reference. And then the JPC, this dot add result is a method I'll build to have the result there. Now the compiler shows an error because I haven't defined these methods, add buttons, add operands and add result. So once I ideally add them, these errors should go off. So once the panels are created, then it's my job to add the panels to the frame. But before that, I should first define what is the layout of the frame. So I would say this dot set layout. I'm trying to set the layout to a border layout. So new border layout of, indicating that the entire frame is split into the north, south, east, west and center. Now if you see, the compiler still gives an error saying that border layout cannot be resolved to a type. So let's try to import that. Now if you observe, a layout is usually a class of the java.awt package and not the java x.swing. That's because layout is not a component. Layout is how the frame actually adds components to itself, right? So you need to understand the difference between importing from java.awt and java x.swing. You need to know which comes from where. Alright, so once I set the layout, then it's time I start adding my panels. So this dot add of, I would start with JPS, the south panel, and clearly indicate to my frame that I am adding it to south. South here is a static final member. So border layout of south. This dot, once I'm done with the south panel, I will then go for the north panel. Border layout dot north. Right, and then I have this dot add of JPC, the center panel. I will clearly indicate that the layout must be in the center. So I added all the three panels, and what's next to do? I should set the visibility to true. Otherwise, a frame by default is not visible, it is hidden. So I set the visibility to true. Now once I'm done with this, I then have to go ahead and start defining my methods add buttons. So let's start defining these methods. These could be private methods, they don't have to be public methods. Private. The return type for this method is a JPanel. So JPanel. The name of the method is add buttons. So what am I supposed to do here? Obviously I'll first create a panel. JP is equal to new JPanel of, and I'll write some logic in between, and I'll return the JP. So the logic of adding the buttons goes here. So let's now start creating the buttons. I only gave a reference here, add, sub, mul, div. These are all the reference of the JButton class. Now what I'll do is I'll create these objects. Add is equal to new JButton of, and what goes into this parameter? The symbol that represents the plus button. Okay, and similarly the subtract new JButton, and that's the minus symbol that I want to be there. Mul is equal to new JButton of. Let's represent multiplication by the cross symbol. The cross, and division is equal to new JButton, and there is a division. So that's the add button, subtract button, the multiplication button, and the division button. So once I create all these buttons, what am I supposed to do? I'm supposed to add them to the panel. So jp.add of add, jp.add of sub, jp.add of null, jp.add of divide. So I added all the 4 buttons to my panel and I return the panel now. This panel gets added to my so I here get the JPS. This gets added to the south of my frame. So that's with the add buttons. I now will go ahead and develop the body for the method private jPanel add operands. So what does this method contain? It contains the text fields, the 2 text fields and the 2 labels. So as usual, since this is supposed to return a panel, jPanel to JP is equal to new jPanel of, and then let me build the body there and return the JP. So let's go ahead, write the logic for creating the 2 labels and the 2 operands. So I'll quickly recollect what the names are, OP1 and OP2, and JTF1 and JTF2. So let's come down here. OP1 is equal to new J label of OP1, that's the name that is appearing as a label. OP2 is equal to new J label of OP2. And then that's the 2 labels, and then I need to create the text fields. JTF1 is equal to new J text field of, we should provide the number of columns, number of characters that can be placed in a text field. So let me stick to 5. That's a sufficient number because we are only looking at operands as numbers, integers. So let me stick to number 5. And I would then also create the next text field, JTF2 is equal to new J text field of 5. So the labels and the 2 text fields are created. Now my job is to add these to my panel. Remember, panel addition is, panel always has a flow layout. So the way you add elements is the way they appear. So jp.add of, I first have to add the OP1, followed by, I then have to add the text field JTF1, and then jp.add of OP2 and jp.add of JTF2. So I added all the 4 components one next to the other in a order that I need to, and then I'm returning that panel. So that's the end of my add operands method. I would now go ahead and create the last method in this sequence, that is add result. So what is the purpose of this method? This method is trying to create the panel for the result area. So JP is equal to new J panel of. So I created my panel, I would return my panel, right? There is a reason why I do this. Whenever I write the body of a method, I usually look at this as a structure and leave the functionality, quickly test it, assuming that there are no errors, and then I would start writing the body. So we usually call this as a stub, where you're trying to define a functionality inside, but before you even do that, you test your whole system, how it integrates with this particular method. So jPanel JP is equal to new jPanel of. So what are the components that we need to add here? There is a label. So result is a label. So let's create that. J label of, and the name that should be there is RESULT. And then you need the JTA, which is your text area. New J text area of. So that's 10 rows, and should we have 25 characters width for the text area. So that's the text area part. Yeah. So just to make the calculator a little more appealing, I would also set some background for this text area. So let's give a slight bluish color to it. So I don't see a reason why I have to remember what blue color RGB values would be. So I'll quickly do a Google here. So let's go. Right. So ask your favorite Google, like what is the RGB values for the light blues. Okay, that's 173, 216 and 230. You should note that the B value is dominant over the other values, indicating that this is more a blue color. So let's get back to where the eclipse 173, 216 and 230. So new color of 176, 213 and 230. Right? It's 173, 216 and 230. You should understand that a color is also an object of a class called color, and color is not a component, so it is taken from again the java.awt package rather than java.x.swing. So I would import color class, and I've set the background for the text area, and I'm returning. I need to add these to my panel. So jp.add of, I will start off with result, and jp.add of, I will then add a JTA. Right, so that's my add result method. So I'm done with adding all these elements. So what I'll do is I'll quickly save this and run this program. So how do I create the frame? So what I need to do is I need to get back to my project package, and let me create a demo class. So I would call this as a calculator demo, which contains the main method. This already exists. So let me quickly see here. Calculator demo already exists. So I've already done this before. So all that is there in the main method is simply create an object of the calculator class. That's it. So let's go ahead and run this particular. Save. Run this. Run as an application. There you go. That's OP1, OP2. There's a result area, and you have 4 buttons: the plus, the minus, the multiplication, and the division. So you would see here in this GUI that there are various components. There is a result area, that's a text area, and there are 4 buttons that you get here. What is lacking here is the functionality. So how many ever times you click these, they don't work because you didn't write the functionality for these buttons. You can't extract the values from OP1 and OP2. That's because you didn't know how to extract those values. So now let's get into writing functionality for this calculator. So how does the functionality for the calculator work? Functionality for any GUI application work. This is where event-driven programming comes into picture. So let's try to understand what event-driven programming is. Now, I've got few components here, 4 components. So when I click on them, I call it as an action, right? So an event is generated whenever an action happens, and every event will generate an object of that respective class. So when I click a button, usually an action event is created. So when I click on this button like this, an action event object is generated. Now there has to be something which holds this object, and the button should know who is the class which will listen to this event. So if button has generated an event, it also should know who is the class, which is the class which will listen to that particular event. That means there has to be another class which is the listener class. So we are now talking about 2 classes. The class where there are components which will create events, and there is a class which is a listener class which will take up some action based on the event. So the listener class actually implements the listener interface. And what's the beauty of implementing an interface? That interface forces the class to write the body of a method, and that is a method which actually talks about what action has to be performed. So event creation listening to the event, and performing an action. So how does all this work? There is a class which contains components which create an event. In this case, it's an action event because you're clicking on a button, and that's called as an action event. Once an action event is created, you also tell that particular button that who the listener is. So this event goes to that listener, and that listener class, what did it do? It implemented an interface called action listener. That action listener interface forces the class to implement the body of a method called action performed. In the body of the method action performed, you will then define what has to be done when I click on the button, whichever button that is. Right? So that's how the event-driven programming works. So let's get back to the calculator class. Now, to keep this entire thing a little simple, what I'll do is I will make my calculator class as the one which contains components and generates events. I will also make the same class to be the listener class. So I'll say this implements action listener. So let me import action listener from java.awt.event. Now look at what the error is. The error says the type calculator must implement the inherited abstract method actionListener.actionPerformed. Right? So let's go ahead. What is the method name? Action performed. So public void action performed of. Now this method should actually take the event object, action event object. So that's the body of the method. So I need to first import the action event. So I need to define the entire action to be performed inside this particular method. So now the question is all about, did the component generate the event? So how do I do that? I will have to go to the component and tell the component who is the listener. In this case, I will have to add a listener. Which listener is it? Add action. Let's take the help of Eclipse. Add action listener. So which is a class, which is a listener class? It is the same class. So you would say this is the listener class. And you do the same thing for the subtract, because you have to do something when the subtract button is pressed. You also do something similar when the multiplication button is pressed. You also do something similar when the division button is pressed. Right. Now that you said that these would generate the event and you need to listen to this particular class, which is the action listener class, I will now go back to my action performed. I will then figure out who has created the event. So there is a method called get source of. Now the source of this event is the add button. Then I've got something to do. If the source of the event is the subtract button, I have some work to take up, some functionality to take up. Similarly, I would then go ahead and do something for multiplication and do L, and also for division. If AE dot get source of is equal to division. So that's the whole set of if statements that I've written, checking on what is the source for each of these action events. But even before I write these conditions, I have to work on the operands. So let me pick the operand values. Let's assume that the inputs are all integers. Int a is equal to, where do I get the values from? J, JTF1, which is my text field, dot get text of. But then the text that you obtain is a string text, and you're trying to store that into an integer. So a good way to convert that is integer dot the static method parse int of, pass on the string JTF1 dot got text of. Right. Similarly, int b is equal to get JTF2, that's the second operand. A good practice probably is not to declare and initialize the values here. I would rather say these two are zeros and then I would initialize these values. There's a reason why I do this that you'll understand probably when we look at more into exception handling here. So A and B are the values. Now what do I do if the source is the add button? If the source is the add button, I also have to declare a variable, another variable called output, which is also by default to 0. So now the output, do I need a variable called output? Probably not, because these are all basic arithmetic. So let's go ahead, let's try to append something into the text area, JTA dot append. Why do I use an append here? That's because I need to append each result to the previous result. So JTA dot append of, I need a string here. A good way to create a string is use the format static method inside the string class. So string dot format of, let me specify the format. My format would be the %d indicating one of the operands, and then a plus symbol. Observe the spaces that I've given there, %d again, and a space equal to, and a percentage b, which is again an integer. And what do I pass here? I pass a, b, and I pass a plus b. So that's my JTA. So can I use the same logic for everything else, except for the fact that this becomes a minus, the output becomes a minus, the next one becomes a multiplication, the result actually becomes an asterisk here, and then you have a division, and then this is also a division. So I'm done with all these operations, so I simply append it to my text area. So I think the basic structure, the basic code is all done. So you said that the calculator class itself is a listener class. That's the reason why you implemented the action listener interface, which forced you to build the body for the method action performed. And we also have the same class which contains the components, and for each component you indicated that this is the class which also has a listener. So that's exactly what you did with this add action listener method that is called for each component, right? So that's the entire build of a calculator, and let's see what issues I have. So let me run this program. Okay, that's my calculator. So I have a 5, I have a 3, and let me start off with a plus symbol. So 5 plus 3 is equal to 8. Look, I forgot a new line character, and that's why the append happens on the same line. So not a very good thing to happen. So let's close this. Let's get back to the string format and put a %n, which is again platform independent. So there's a reason why I used string.format, because string.format gives me that flexibility to use a %n, which is a platform independent delimiter. So %n. So save, run it. That's my calculator again. 5, 3 plus, that's 8, minus, times. I can change that in between, say a 2, and yeah, that's an integer division. So 5 divided by 2 is a 2. So that's how the entire result is. But then the problem with this program is if someone types in some stupid string there instead of a 5 and then tries to do arithmetic addition, the program terminates because of a particular reason. There is an exception that is thrown. And let's figure out what the exception is. The exception is a number format exception. Why is it a number format exception? That's because you're trying to convert the string to a integer using integer.parseInt, right? Where the return type of that parseInt method is an integer, but this cannot be converted to an integer. So I need to put this into a try and a catch block. So let's quickly do that. So once I create the two members, so let's put everything inside a try block. That's easy, but again not a good practice. A try block should always have minimal number of lines into it. So that's my try block, and let's see what the compiler says. It says insert finally to complete block statement. So you need to understand a try block cannot be there all by itself. It should either be succeeded by a catch block or a finally block. So I would write a catch block, and what is the exception? Number format exception. So where is this number format exception class? It is in the java.lang, and that's the reason why I don't have to import, is that? Yes. Duplicate parameter AE. I've already used AE for action events, so let's change the name NFE, indicating number format exception. So what do I do here? I simply say jta.append of, what do I append here? I append again a string.format, and I would simply append one single string. Percentage uppercase S indicates that the string gets converted to uppercase letters. So, and what do I pass here? I would simply say this is a number format exception. So I would simply say incorrect input. Right, there is a percentage N as well. So that's with my catch block. So let's save, run, and let's see what happens. So 5 and 2, I add, subtract, and I change this to some crazy string. I add, it says incorrect input, I subtract, incorrect input. So it will give the same incorrect input till the time I change this. So times division. Perfect. Now that's making my calculator more robust, where independent of what kind of inputs the user gives in, I'm putting in all the exception handlers. So that's a good robust way of building an application. Now I have again another problem that I have to look into. When I convert my operand 2 to a 0 and do a division operation, again the program terminates because it's an arithmetic exception where it is dividing by 0. So let's also try to add that catch block here. So a catch block for arithmetic exception. Right? It's not the number format exception, it's an arithmetic exception. Arithmetic exception. ATE. Yeah, and what is the string that you want there? Cannot divide by 0. Perfect. So let's save it again. Let's run it. And this time, let's see if it permits me to divide by 0. Let's do a division operation to begin with. It says cannot divide by 0. Now I change this to 2, do a multiplication. It does the multiplication. So 3 addition, yes. Subtraction, yes. I change this to some string and then perform a division. It says incorrect input. So that's how you make your calculator more robust. Irrespective of what kind of inputs the user gives in, you put in all those exception handlers into your code and you make it more robust. So this particular example, you have seen how to use interfaces for event-driven programming. You also have seen how to built in some exception handling, especially for the runtime exceptions. Both number format exception and the arithmetic exception are both runtime exceptions, and they're unchecked exceptions. And you realize that they're unchecked exceptions because the compiler did not stop you from compiling, even if there is a chance of a division by a 0 or a number format mismatch. Right? The compiler did not push you to handle this exception, and that's why we call them as unchecked exceptions. Whilst the checked exceptions like file not found in IO exception, all these are checked exceptions where the compiler forces you to handle those exceptions even before you compile the program. It doesn't wait till you run it. Right at the compile time itself, it forces you to handle those exceptions. So that's a quick example of how to use event-driven programming for GUI applications and how to also make your program, your solution more robust using exception handling. So I would recommend you to work on a little example where build a GUI where there are two buttons, let's say green and red, and when you click the green button, your frame should turn into a green color. You click the red button, the frame should turn into a red color. So I want you to work on this particular application, and I'll post the answer for that in my next video.